Versa Director with appropriate privileges. Go to Workflow, click on Template and click on Create Template. Once you click on Create Template, the Create Template window opens. The first step is creating a basic configuration for SD-WAN. In the Basic Configuration tab, we define the template name, type of template, associate the controllers, the analytics cluster and define the subscription tier. Configure a name for the template. The template name has to be unique. Next, we have to define the type of template, staging or post-staging depending on the design. Staging template will have limited set of features, for we will be able to configure the WAN interface only towards the staging controller. Once the staging is done successfully, the post-staging template will be pushed, and then connection with post-staging controller will be established. Associating the staging template with a post-staging template will be done while creating the device groups. However, in this example, the template we are going to define as a post-staging template and the controllers used here function both as staging and post-staging controller. Next, we have to map the template to an organization. In our example, this template is going to be a part of the Versa organization. In a multi-tenant environment, we need to choose the correct organization under which the template must be created. The next step is defining the type of device template. We can define it as a SD-WAN or a UCPE, Universal CPE template. Next, at the type of overlay topology that this template is going to have, full mesh or hub and spoke. In case of a hub and spoke topology, we need to define if this template is that of a hub or a spoke. If it is a spoke, we need to define the spoke group to which this belongs. So, spoke groups have to be created before creating the template. Spoke group is where we define the type of communication between the spokes, spoke to spoke direct, spoke to spoke via hub, or spoke to hub only. In this example, we will create a full mesh template. In addition, starting release 20.2, you can define a template for hub controller. A hub controller node is one which functions as both a hub and a controller. This is a use case when we don't have the transports available at the first level controller in a particular region. In this case, spokes establish IPsec tunnels to the local hub controller nodes. Only hub controller nodes connect IPsec tunnels to the high-level controllers. Next, we define redundancy while creating templates. In this example, we are creating a high availability template, 2 CPEs deployed with device level redundancy, and this is done by enabling the redundant pair configuration. We will enable VRRP on the LAN between the 2 CPEs. The second or the redundant box template has to be defined here. The Versa Director automatically creates the secondary device template with the name we have given. We can verify this in the Device Template menu under Configuration tab. The next step is to define the controllers. All the controllers or specific controllers alone which are a part of the SD-WAN headend need to be added. Versa recommends to add at least 2 controllers in a multi-controller setup so that there is a controlled connection redundancy from a branch perspective. The next step is to add all analytics clusters which are present in the SD-WAN headend. If this is not added, then we will not get analytics logs for the devices created under this template. And finally, we need to specify the subscription license ordered. You can choose for the different subscription tier depending on the features the customer has ordered for. The service bandwidth can be defined in the template and will be applicable to all the devices created under this template, or alternately, the service bandwidth can be defined while creating the device, in case the service bandwidths for the different sites are going to be different. Now we have completed the basic configuration for SD-WAN. Next, we have to define the network interfaces. Click on Continue in the Post-Staging Template window to configure the network interfaces under the Interfaces tab. Interfaces tab. Now, we will define the LAN and WAN networks of the device template. We will define the configuration for WAN and LAN links under the Interfaces tab. First, we will have to define the WAN and LAN ports in the primary and secondary boxes. We will begin with the device port configuration on the first box. The device ports numbered translate into the OOB management and virtual network interfaces for the SD-WAN. In this case, port 0 translated to ETH0 or the OOB management, and port 1 onwards map to SD-WAN interfaces starting with VNI 0 bar 1. We will define VNI 0 bar 0 or port number 1 as WAN 1. Port number 2 or VNI 0 bar 1 is LAN. And port number 3 or VNI 0 bar 2 is the cross-connect port between the CPEs. If you notice, in a high availability template configuration, once you define the LAN and cross-connect ports on the primary box, The same ports on the secondary box also get mapped as LAN and cross-connect ports. The next step is to enable any WAN links on the secondary box. Here we choose port 1 or VNI 0/0 as WAN interface on the secondary box. Next, we will have defined the configuration for the WAN links. We have to configure a network name for the transport links. If it is a new network name, then you have to configure the network name and map it the transport domains, either MPLS or Internet. Here map the WAN transport on CPE1 to MPLS and that on CPE2 to Internet. Next, we have to define the type of IP address, IPv4 or v6, and if it is going to be a static or dynamic IP address on the WAN interface. There is an option to allow SSH into CPE. This can be permitted or denied considering the security compliance of each customer or provider. As a best practice, it is advised to block the SSH access on Internet links at least and allow it for VPN or MPLS circuits. MPLS being a secure environment, we can enable it to have access from a jump server or a bastion host. Repeat the same for all the WAN links. Next, define the LAN configuration for the branch site, network name and associated organization. The routing instance automatically gets populated. In case there are multiple routing instances associated to an organization, here we can choose the routing instance to be mapped. Creating of a new LAN routing instance or LAN VR with different community values is outside the scope of this training. The remaining tabs contain information which are not mandatory and only required if those features need to be enabled as part of the design requirement. However, we need go through all the tabs before the device template is created and deployed. The gear icon wherever present can be used to make the field as a variable, the value for which must be entered during device soft onboarding or device creation. At this point we have basic minimum information for a device to be onboarded. Click on Continue on the template creation window to configure the routing tab. Routing. Under the Routing tab, any LAN-side routing or if required WAN-side routing can be defined. The appropriate routing instance has to be selected under Network before configuring the routing. In addition to static routing, Versa support BGP and OSPF protocols. Before configuring static routes, it is good practice to know in advance, and then incorporate as in the design, the number of static routes need to be added. The routes themselves can be hard-coded, or be parameterized using the gear icon, and then be defined at the time of creating the device configuration. Click on Continue in the Create Template tab, and move to Tunnels. Tunnels. In the Tunnels tab, configuration related to split tunnels or site-to-site tunnels can be defined. Split tunnels has two configurations, DIA, and gateway function. DIA is a configuration, where the internet-bound traffic from the LAN takes the local breakout to reach internet sites. To configure a DIA, we must specify the LAN VR, and associate it with the internet transport or the internet-connected WAN interface. The other option here is a gateway. This can be used in two ways. 1. If the customer network is a brownfield deployment and on day 1, it will have both SD-WAN and non-SD-WAN sites. To enable communication between the two, we can configure the gateway option, which, when configured on the VOS appliance, leaks the SD-WAN routes into the underlay. Thus, the appliance acts as a transit point between the SD-WAN and legacy MPLS domains. And the second is if we have a central internet breakout, and we want that default route to be sent to all other branches over the SD-WAN, then we need to enable bot DIA and gateway in the central site. If there are any site-to-site tunnels, they can be configured here. Like, an IPsec with another site, or a third-party service like Zscaler, or a simple site-to-site IPsec. A separate VPN profile needs to be defined under the VPN profile configuration. Inbound NAT. This tab is used to define any inbound NAT translations. This is a straightforward NAT translation, where we have to define the WAN network and the LAN routing instance and the external and internal addresses like any other NAT. This can be used if there is a web server behind the VOS appliance on the LAN. Again, these are not mandatory configurations and are optional, only in case the site design demands it. In the Services tab, we can configure optional services that may be required on the branch site. We can configure DHCP server, relay and firewall service templates under the Services. Enable DHCP server functionality on selected LAN interfaces where Versa VOS appliance acts a local DHCP server. DHCP relay functionality on selected LAN interfaces to point out an external DHCP server. Service templates provide way to define network-wide common configurations based on specific network function/service. We can define the security templates like a NGFW or SFW to be attached to the device template. Management servers. This tab is used to integrate third-party management and access control services. We can define the NTP servers for time sync if the organization has one, or we can sync it to the Internet time servers. Versa today supports TACACS+, Radius, and LDAP for user authentication. We can also integrate third-party syslog and SNMP managers with the Versa VOS appliance. VOS will upstream the logs to customers' NMS and syslog servers provided there is reachability. These can be hard-coded in the template, which mostly is the case as these would be common across the organization. But, if the customer needs to have this as a parameter which would be given at the time of creating the device, we can parameterize the configurations. Click on Create to create the device configuration template. We have now understood how to create a device template. In the next section we will understand how to create a service template.